Hi everyone, Masudi here, and
Hi guys, this is Dimo from Mass OD.
uh, this is the beginning series of the videos around the Kotlin in focus subject, and in this video we are going to talk about the the Kotlin properties, and for that, and we've had some videos about it. We've had some motion graphics, short video clips that I strongly encourage you to go and watch them. And for example, 4 or 5 videos clips, we are going to have uh, another video like this that will focus on the subject, and we will have some examples to elaborate on the subject more. So we want to talk about the Kotlin properties, and also before going to the subject, before showing what is the Kotlin properties and how it is being defined and how we can use them. Before that, I want to first show a snippet code, a simple code of Java, to just show the difference. You don't have to know Java, and don't worry about that. It is a simple code. I just want to show the difference and show you what is property and what is a field, because each language has its own approach to defining variables and values, and some of languages let you define fields, but some of them are all about properties.
Okay.
They don't let you to define field, and now the question rises that, okay, what is a field and what is a property? So if I want to show that, just consider this Java class. It's a Java class, Java file. We have a Java class here named person, and we have another class here, for example, runner, for example, which will run and which have a simple main function method that we have instantiate an object of this person. So say this person has an int field, not property, int field named age, which indicates the person's age. Okay, so now if I have access, it is obvious that I have access to that age, and I can assign values, and I can print the age. If I run the application, the age will be printed 20. But what happens if I assign a negative number to this age? It won't prevent me, because it is not syntactically wrong. It is semantically wrong, because age cannot be negative. But age is a field, a placeholder inside the memory of type integer that can hold integer numbers, and integer numbers can be negative and positive, has a predefined range. So if we want to prevent assigning wrong values, which has wrong meanings, not wrong about integer, wrong about age, if we want to prevent that, the solution here is to make it private, and just don't worry about these keywords in Java and private, and I just want to show you the difference, And we will soon go to the Kotlin, and by writing this private, we are actually hiding this age, hiding this field, because this field gives the control to the user to assign whatever the user wants, because it is simply a field. And if we want to control what values are being assigned to, we have to first hide it from direct access. Now it is complaining that there is no age or it is been hidden. Then, and what is the purpose of this field after all? The purpose is holding some value and asking the value off of it. So for setting a value, then we provide a public function, which, let's get rid of this public. I provide a setter function, they say a setter, which will set this value. And for example, let's say set age, which will receive age, new age, for example. And here, for setting age, I have to call that function. And I have to pass my value through this function. Now, because I am calling a function, a method, if you will, a method here, because I'm calling a method a function, and because I can write a logic about controlling what the
ages,
what the acceptable values could be. So now I have control. Now I say if new age is less than 0, for example, through an exception, through an error, say age is not acceptable. Age is not, or cannot be null, cannot be, negative. Or, and if the age is not, I have typed there, let it be.
When A is extra, negative.
Negative.
No, that's A true. After T, we don't.
Okay, yes, negative. And if new age is greater than 0, then we just simply go ahead and assign it to the field that we have. We assign this value to the field that we have. Now, if we run it, this code here will crash, will scream, and the user of this class won't be able to assign wrong values, even unintentionally. And now if we want to ask the value, because we say we want to get the value and print it or show it to user or use it somewhere else, again, we don't have access to the age because it has been hidden. So again, we have to provide a getter. That was a setter function, and this one is a getter function. Get age, which will, for example, simply in this case, which will return the age simply, because there could nothing go wrong in returning the age, and also because it's a function now. Also, we have control on when it is being fetched, when it is being requested again. But when it was a field, a simple field, again, we didn't have any control on when and how it is being fetched, for example. Now say, for example, we can have some logic about counting how many times it has been fetched or asked. So now if we want to use it, we must to call the function. So for this field, in order to prevent the users from assigning wrong values, unintentionally wrong values, we first made it hidden. We first hid it, then we provided a setter function or maybe a getter function. Not always we have to provide a getter for all of them based on our application and use cases. So I provided a setter and a getter function. And then from there on, the user of this class has to go through these two functions to set and get the value. So this is a field. A field is simply a placeholder inside the RAM, inside the memory, which has been reserved for you. For example, your memory is 4 gig and it has been reserved some bytes for you, 4 bytes, and has put the name age on it. And the language, the Java, lets you to assign acceptable integers to it. But again, I'm saying that for preventing, based on our domain, based on the meaning of this age, we want to prevent a subset of range values. So this is a field, and they call these three in a group, in a bundle, a field, a setter function, and a getter function, or a field and a getter function. We call this group a property. So this is a field. A field is a dumb memory, is a dumb piece of memory somewhere inside your RAM. But together with a setter and a getter, which controls the field, they call it a property. It is
all of them.
Yes, all of them. All of them. They call it age property. This is age property, but this is age field. So with that said, let's go to Kotlin.
That is something different between attribute and
yes.
property.
No. Properties is something like attribute. Of course, it's other name. Maybe the other name of the property is attribute. But field is very,
So we cannot. Excuse me for interruption. We cannot make another field here and then print it here.
Where?
Is it necessary? For example, make an int here.
No, we can. But it is a setter function. Setter function is not returning anything. It is about setting.
That's false.
But
how about putting this one here?
The setter. Why?
Is it? It doesn't work now.
No, no, because the setter is returning a void. It's not returning. The purpose of setter function is setting the value. It should not return anything.
Because of return.
And also it is very dumb, you want to merge those two functions into one just in order to make it easier to access the value. But then every time we get the value, we have to set it also. That is not a good idea. This is the standard.
Maybe that's for other session to ask it. We can make just one function.
No, it is not possible.
Also, it can also return and also do this work.
Then in order to ask the value, every time we have to set it also as well. That is not a good idea. So maybe you set the value one time.
We can pass a parameter then.
Okay, we are passing this parameter. I know what you're proposing here.
Check if the parameter is not null, then assign it. Or
I see, but that is not a good. That is not a solution to provide to everybody, to suggest to everybody to do this. This is the standard way.
Okay.
They call this the property age.
Property of age.
Yes. I want to replicate it in the Kotlin side just to see the difference. So this side, I write the class person, and just don't worry about this class and these things. We will cover them later. Just focus on the property. So I've written this class person, and this class person here for defining a placeholder, we use the var keyword or a val keyword. Var keyword is the short for variable, and you use it as a placeholder like the age that we had. We write the age and then the type comes after here. Here we first wrote the type and then the name, and this is a variable which this age can be changed, and can be changed the value anytime. But here we should explicitly say that I want this age a variable. And now it is asking me for an initial value. let's give it an initial value 0, and I will say that what's the reason about that it is asking for that. So now I'm going to create a main function here to use that class person. So first I create a user, an instance of the person. Here I created it, yes. Then I want to assign the age. Let me have a value, val. Also see this, val is short for value. Person equals person of type person equals person. So I've instantiated this class person here.
Without new keyword.
Yes, without new keyword. We don't have the new keyword. And we will cover them later, the class and new keyword and all that other stuff. So now we are assigning this to the person here. This person here is a placeholder, which can hold onto values of type person. And I have instantiated with this. And because it's a val, I cannot change its value. But our main focus is this age here. I don't want you to focus on this person value here. So person dot age equals -20. Okay, and there is no need for semicolon. Now again, I am assigning negative values like the Java side,
Yes.
which is semantically wrong, has wrong meaning because age cannot be negative. But this time, the age here is a property. It's not a field. And you may ask, okay,
how come?
Yes, how come? What did change here? What is the difference? This is a property. Being a property means that you have a setter or getter somewhere that is controlling what values are being assigned and when it is being fetched. So where is that setter and getter? This time with the Kotlin, you don't have to define some separate functions inside the class and name them somehow.
Setter and getter.
Yes, setter and getter and something like that. We write them directly below each property, not field. Just pay attention to the words. So for each property, because it's a variable, it means that it has a setter and getter. But it has a default setter and getter, and because it's a default, we don't have to write it. It's been written for us. Now I want to write those default setters and getters. This is set. We, for example, name it value, the parameters that it will receive, and a function. And also, I want to write the getter function. So you can see that set and get is a keyword here. It's not the name of a function. I cannot name it an arbitrary word, you know. It must be set and get. And they, with this, trick, they have made the code smaller. So inside the setter and getter, we have access to some special value named field. If we write field, you will see that it's of type integer. So this field, they say this field is the backing field of this property. Here, in this property, we have a backing field, yes? This is the backing field. This is the memory that backs these two, these setters and getters. After all, we need a part of the memory somewhere to store the value, a backing field. So again here, we have a backing field which is accessible only inside the setter and getter function of this age. So this field points to the backing field of the age. And if I assign it, I've assigned the field the received value, and also if I return the field, you will see that it is saying that redundant setter, and also here redundant getter. They are redundant because they are the default functionality. They are the default ones that will be written on your behalf, and to make it, the code smaller. But and you may ask at this point that nothing has changed here. Okay, we have a backing field, we have some beautiful code, prettier code, but nothing has changed here. But let me first just have the logic here. I will say if the value, and by the way, you can say this value is of type int, and also this is redundant because this setter is the setter of this int field, and this is redundant. It is saying that okay, you can get rid of this just to make the code smaller. I can name it V. No, the name doesn't matter, but this field matters. This field should be field. So I'm saying I will receive a value.
Field is necessary.
Yeah, field is necessary. You can see that it is making bold and underlined.
By default, it's field.
That's the backing field. Yeah, you cannot change that, and it is only accessible the field backing.
Field means age.
Yes, the memory of the age. So I'm saying if value before assigning to the field is less than 0, then just throw an exception and tell that it is wrong. This value is wrong, or something like that. I'm throwing exception. I'm preventing it from being assigned wrong value. But if that's not the case, then we assign the value to the field. And the getter is simply like this, and I can get rid of it, or I can make it be there. Just leave it there. Now one thing that has changed here, I want to first come to the Java side. After making a field to a property, then we have to go through this ugly way of calling functions for setting and getting the values. Then this is that we have no choice, because we have hidden the backing field, and we have provided some setter and getter. Then everybody should go through these functions to set and get those values.
Yes.
And this makes the code very, verbose, and we have set age, get age all over the code. You will see in the Java code we have set, get everywhere. But what if in the Kotlin side you can see that it is like we are assigning a field, but we are assigning a property. We are calling this function. This is calling the function on our behalf. So the code, now if I, for example, want to print it, print ln person dot age again, we don't see set or get here. There is no set age or get age. We are using simply by accessing the property. Then when we access the property, it will call the getter for us every time. And if we assign something to the property, it will call that setter function every time for us. So this makes it a property. So this is a property from day one, from the start. This is not a field. It has a backing field, yes. It has a backing field. But it is a property because it has a setter and getter. Now if I want to show you, the magic of the Kotlin side, the beauty of the Kotlin side, let's say on the Java side, I want to add another field, another property, which tells if this person is old or not. So for that, I should write this function because being old or not is a logic. It is not a field that has been set somewhere. We have this boolean and we ask is old, yes, and for returning the value it will calculate whether or not the age is greater than 60, for example. If the user's age is greater than 60, then we consider that person old. So again, sorry about that, we can use that property. This is a property, but we are calling it through a function to access it. Is old is a property of this person, which we are asking, are you old or not? But again, we have to go through this function. You may say that, okay, you can make this is old another field, a Boolean field, not property. Okay, then I would say when you are setting the age, I will check if it is greater than 60 and I will set it true or false. But then, if I don't make it private, I'm giving the permission and access to everybody who has an instance to change it true or false, ignoring the age itself. So I have to make it private, you know, I have to make it private and I have to calculate it myself. But in order to do that, we have again to go through this ugly way of creating a function and getting, we have this is old, get age, and but now let's come to this side, to the Kotlin side. So this is old is a property. It's not a field because it is not being set. It is being calculated every time based on other properties and fields. So this is a val. This is not a var. This is not a variable. We don't want to make the users being able to set it. This is a val. We name it is old. This is a Boolean of type Boolean, yes?
Yes.
And this time we cannot have a setter here. If I say set value, you will see that it will complain that a val, it is saying that a val property cannot have a setter, because it's a val. It is not going to be set, but it has a getter, yes? It has a getter, and inside this getter, I am going to return age greater than 60. Now if I want to use it, you will see that I can use it simply by calling is old. And there is no function and parentheses, open parentheses, closing parentheses, nothing. It's like we are calling a field, a memory somewhere. But we are actually, every time we are accessing this property, which will each time call this getter functions on our behalf. And each time it will calculate it for us. So by comparing the Java side and the Kotlin side, I just compared it intentionally. I started from the Java point of view to show you that how Kotlin is making our lives easier. And also we have properties or fields, one of them in each language, you know, because in each language we have to store our value somewhere and retrieve them sometime later, or modify the value of some of the placeholder. I'm saying placeholder because this placeholder on the Kotlin side is a property, on the Java side is a field. And this value here doesn't have a backing field. Why? It has a backing field, but I have overridden the getter function, and I've not used the field here. Because I have not used the field here, then the Kotlin will remove the backing field because it's simply a function. But if I, for example, get rid of this getter, and I, for example, assign a false value, for example, I can do that. It's a value. It can only be assigned only single time, and this value won't be changed.
That's false.
That's because, and this false is being stored somewhere. Where is that somewhere? That is the field, the backing field of is old. So even the values have got a backing field, like the variables. So no matter if you define it a var or a val, it has a backing field. It will use a backing field for itself. So if I, for example, say getter return field, I can see that you have a field. You are seeing that. For example, each time I want to negate that field, for example, just very odd. But you can see that we can override the getter, the default one. The default one is this, return field. This is the default one for a value, as well as this one. And it is saying that the redundant getter, we have a redundant getter. But if we want to calculate it in this scenario, in other scenarios we might want to only assign it once and let it be there, but in this scenario we don't want to use the backing field. We want to calculate it every time. We want to say just calculate it based on the age. Okay, so with that we can wrap this session, and you have been introduced to the property and the difference with the field, and also the var and the val. I've used this val here also as well. It is not necessary to use it in the class, but I wanted to use it in the class to override the setter and getter, because when you use it inside a function, it is like just it will act only as a field, you know, because you cannot override its setter and getter here. It will just only act as a placeholder, a simple placeholder. And yes, if you don't have any question, any comment?
No, that's okay.
Okay. Yeah, I think we can
Finish it.
And in the next sessions, we will talk about the rest of the things around these properties inside the Kotlin. Because we have nullability, null safety late in it, we can make them late in it, and all those stuff we will talk about. Okay.
Thanks for watching us, guys.
Thank you and bye.
Goodbye.